So this is project log for the So this is project log for the collapsible hurdle. You might ask, Jasper, where's the hurdle? Well, I sort of took it apart because, okay, so to give you a bit of context, today I went to meet my client who ordered this, and we went over how the hurdle functions and all that. One of the main problems that he had, oh Jesus, okay, we're not gonna point my camera that way, but one of the problems that the client had was when we attach this not additional part, but when we attach this part, and when something collides with the hurdle up here, and by the way, technically this is supposed to face the opposite direction, but whatever. When it collides with something up there, you can see this aluminum pipe shaking like that. And, this problem isn't very inherent when I put it on a desk and I fix it with my elbow. My elbow was here. When I fix it with my elbow and make it stationary, but it becomes much more problematic and inherent when I add this. That's, by the way, the actual hurdle, a part that goes into the actual hurdle. Now, if something collides up here, oh, Jesus, I don't want to break my monitor, but it's the force, well, you know how torque works, right? So if I apply force here, even if it's just a little bit of force, it's enough to make this entire stand wobble. I think, well, right now only this part's wobbling because I haven't fixed it yet, but yeah, you get the idea. This entire thing wobbles. So, I think that's owed to two problems. One is that, oh geez, I do not want this on my desk for a second longer. One is that I redesigned this bottom part so that it sits flush. That's great. If we were, trying to make it as flat as possible. The problem is when stress is applied, this part, see, it stretches or it flexes because it's plastic and it does that. Whereas the parts that I've made traditionally, not traditionally, but the parts I've originally worked with, they had this part covered, and since these two sides were bridged together by a top side here, it enabled it to hold together with a much stronger integrity. So that's sort of that's one problem. The second problem is that this I don't know how you would say this. Oh well, this end cap here, this end cap does not sit flush, and it also doesn't help at all that it's chamfered. It doesn't hold it in place. And one other thing is it's only held in place here, and as you can see, this is a lopsided joint, which means this pipe, I call it A1. This A1 is only connected to the joint at this bottom level, and this A2 is only connected to the joint at the top level. And what that basically allows it to do is when it's flexing in that direction, so it goes like that, there's nothing keeping it from flexing, right? The only thing that's keeping it from flexing is this, this plastic attachment right there, right? The 3D printed connection. So I've gone ahead and designed a second version of this joint, and it looks something like this. Now you might be wondering, what is this? Well, it's very simple and it's much more compact.